Welcome to my recording for microprocessors. Here shows my collection. So during my assignment, I've done in total 7 builds. I tried to show the progression, so starting with build 1, going all the way through to build 7. So for build 1, it's very basic. It's just the generic floodlight with a motion sensor. Moving on to build 2, which is adding the potentiometer to change the light sensitivity and adding a switch that will allow the light to stay on permanently. Next, we added the ultrasonic distance sensor, again with a potentiometer, so you can change the distance at which the object has to be to this device. In the fourth build, I added in the buttons. So these will go through, so I've got a button that changes it to back to white. If you change it to blue, green, red, and this is a cycle. So when this button's held down, it will just cycle through them. For my fifth build, this is adding the temperature sensor and the gas sensor. Not much else has changed from this one. And this is my sixth build, which I left it at this. So I didn't have a Bluetooth HC05 module, so I just demonstrated where these cables would be plugged into the Arduino. For the code side of things, starting at the top, got a library added that is used for defining the digital ports to be used for transmission and received with the Bluetooth. I was just using the normal one, so 0 and 1, so I still defined these anyway, and then I created the software serial object. These are all my defined pins and any variables that I've used throughout. Then we come to my color array and my struct. So my struct states the name and the color values. So these can just be called instead. So in my code, you'll see that it calls the name, which is like white, blue, green. And then it will assign these variables, well, these values to the RGB light. For my setup, it's just the bog standard pin modes, so turning a like input, output, and starting stuff as low. So in my main loop, it's calling 3 functions. It's reading most of the digital and the analog reads, and again, the serial print, that is just for testing to make sure my values are coming through correctly. Next, we move on to light intensity. So this is made up of a bunch of if statements. So the first one states if the main switch is on, it will keep the light on, but then if it's not, it will keep it off. Then it will go to the next one, which is reading the light value from the photosensor and then the value from the potentiometer. If the light value is lower than or equal to this, it will then check the light threshold to see if it's false. The light threshold is used so the light will only come on for 5 seconds when it reaches that initial threshold once. So we use threshold to stop that from happening again. So this will then run floodlight, which is literally just turning the light on for a set amount of time. It will then set the light threshold to true, so it stops that from running again. It next checks the light value and again send read again, and this time it checks to see if there's any motion. So from the motion detector. If it does detect there's motion, it will then go to the ultrasonic sensor and see if it picks up a ping to an object. Again, this is being compared to the potentiometer for the distance, which can be set by the user. And if these conditions are met, it will turn the light on for the stated time. Then if none of us, once the light value goes over the light sensitivity, the light threshold will be set to false and the light will turn off. We have distance ping here, which is used for the ultrasonic sensor. So this calls get distance duration, which is right here. So for the ultrasonic sensor to work, you have to set it as an output, so it will send a ping out. It then needs to be set to input so it can receive the ping back in. This is received in microseconds, so that we have this other function down here which will set it to centimeters, which can be seen here. This again is printed into the serial, but this would ends up being removed due to testing purposes. Finally, we've got read color buttons. So these are the buttons on my board that can set to white, blue, green, and cycle through the colors. So I've got digital reads here that will just read if the button's on or off, and then it will go through the if statement and change it to the color stated in the array, which you can see down here would then, wait, where is it? Here. So then it will set it to the current color using this for loop. And then from here, it will select which one it has to go into the red, green, and blue pins. For the cycling, that uses a different function. So this uses cycle colors. So this is just an if statement. So it will just cycle through, incrementing the numbers up until it gets to the highest, and then it will go back. Finally, we have Bluetooth sensors. So this is reading the values from the temperature sensor and the gas sensor. For the temperature sensor, have to use this equation here, which will calculate it into Celsius. Then we use the map function, so it maps to the actual values what it can read. So for this example, it can go to -40 up to 125. Originally it's from 0 to 1023, but that's been changed to these values here. For the gas, that's also been changed, so we changed it from 0 to 100 to make it a bit more easier to read and then compare against. Then we use BT serial, which will print those values to the Bluetooth serial. So for the 7th build, again, hardware is exactly the same as the 6th build. In this one, it's just got the optimized code. So in here, I removed code, used port manipulation, and things like that, trying to get rid of digital read, digital write, analog read, and also analog write. So to begin with, I added more libraries. These ones were needed for PWM and also the analog read and write functions. So I'll describe them in a minute. So from this point, nothing's really changed apart from here. Instead of actually defining the ports like pin 13, 12, all that type of stuff, I've used the registry. So we've got PB0, then got PD2. So when we're doing the port manipulation, I can call these instead of stating a number, so it knows how many increments the binary digit will have to move. So setup has been dramatically reduced. So now it's only there's port manipulation here, and running this setup PWM, which can be seen here. So the whole point of this is just to allow for the manual change of the PWM duties, because my RGB light had to be connected to a digital pin. So in order to get away from the analog write, I had to go down this route. Next, we got read from ADC. So this is to set up the ability to read from the analog pins. So we've got an ADMUX registry, which allows for the reading of the voltage from the pin, from an analog pin. We then connect that registry to a ADSC port. And after that, we run a while loop. That's literally while there is still data that needs to be read, it will keep going. And once it's finished, it will clear the ADSC port. And then it will return it as ADC. The main loop has been like dramatically reduced. So I got rid of all the serial prints, all of the digital reads, anything like that. So it's literally just calling the 3 main functions now. So for light intensity, because we're no longer using digital read, analog read, or anything like that, for every if statement, the port manipulation is done there to get the value. So for every if statement, it's getting the information there and then. So as you can see here, so this would be an analog read, this would be an analog read, so this would be an analog read of the photo sensor, this would be a read of the potentiometer. Moving down, so again, the same example here, this is reading the value of the motion pin, which is our motion sensor, to see if that one's on. Here we got, again, reading for, this is the potentiometer for the distance value, which the user can change, and so on. So the next bit that was changed was the get distance duration. This has all been changed to used the port manipulation now. So using the data direction registry, using port to state if it's high or low to send the pings. So that is all done this way now. Then following on to the read color buttons. So there is no longer digital read to see if the button has been pressed. It's now done in every if statement. So as I said before with how I set up the names to use the port numbers, so now I'm able to see what each of these actually do instead of just being a generic number. So it makes it a bit easier to read. So continuing down, so BT sensor also been changed, so it's now using this read from ADC function to get the value, so just to get rid of analog read, and it being put straight into the print function. The same with the gas readings. Finally here for LED on and LED off, this is using the PWM duties. So again, this is getting selecting the array. This is stating which area of the array it wants, so white, blue, red, anything like that, and it will set the pin values to that. But this is using the PWM duty now. So for this one, PWM duty again, but it's just setting all the values to 0 for those different pins. Finally, we have the mobile application. It is a bit bland. It's got the bare minimal functionality, so it's got current temperature and current gas levels and a connect button. So if I show the blocks, so the list picker will allow you to pick an element from the Bluetooth devices that are connected. So then after it's been picked, it will try and connect to it, and the text will change to connected if it is. We then have a timer that we use to increment in the values, like the readings from the Arduino board. So it will check if Bluetooth is connected. If it is, then it will call the bits from the available Bluetooth device until there's no bits left. This then initializes a list that's called readings. From here, it opens the list, and the readings that it's got from the Bluetooth device, it will split from the new line. So in this code here, I'm using a new line, so we know when the code is being split. So here it will set the first bit of code to be an index 0, and that will be set to temperature readings. Then index 1 will be set to gas readings. The next is 2 more if statements. So these are for the temporary alerts that will flash up on the app. So if temperature is equal to or goes above 30, it will read high temperature detected. And for gas, if it goes above 70, it will read high level of gas detected. So all in all, I've done 7 builds, and I have built some of them in person up to a point until I no longer had the components to do so. But thank you for listening to my video.